Hi everyone, today we're going to be doing some examples involving Fibonacci numbers, and let's just review the idea behind Fibonacci numbers. So it's a sequence of numbers and it starts with 1 and 2. So F1 means the first number in the Fibonacci sequence, F2 means the second number in the Fibonacci sequence. And to get the nth one, you add the n minus first and n minus second. So this means you add the two previous. So we have F1 and F2. To get F3, we add them together. 1 and 1 is 2. To get the next one, 1 and 2 is 3. 3 and 2 is 5. 3 and 5 is 8. 5 and 8 is 13. 8 and 13 is 21. 13 and 21 is 34. 21 and 34 is 55. 34 and 55 is 89. 55 and 89 is 144, and on and on and on. The sequence keeps going on forever. Now let's go ahead and do a few examples involving the Fibonacci sequence. First, we want to find the value of the following. F12, so the 12th Fibonacci number in the sequence. So the 12th in the sequence, so we just count this as 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, and 12th. So F12 is equal to 144. Now we want to find F12 minus 4. So what we're working with here is the difference between being down in the index, which Fibonacci number it is, versus being up in the operation. So in 2 and 3 here, we see 12 minus 4, right? That negative 4 is down in the index. So that's actually F8. Whereas this, the minus 4, is totally separate. So it's the full F12 minus 4. All right, so the 8th Fibonacci number in the sequence. So one common mistake, right? You see the 8 and you think, oh, it must be 8. But this one means the one that shows up 8th. So in the 8th place, 1, 2, 3, 4, 5, 6, 7, 8. It's actually 21. And here, F12, well, we know that is 144. We take off 4, and we get 140. All right, here we have a similar comparison. F12 over 4, that's all down in the index. 12 over 4 gives us 3, so we want the third Fibonacci number, which we know is 2. And here we've got F12, the whole 12th Fibonacci number divided by 4. So we've got 144 divided by 4, and when we do that out, it turns out to be 36. Okay, let's go ahead and do another example, which is a little bit similar. And let's remind ourselves the sequence down here: 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89, 144, and it keeps going, but we don't need to go that far. So let's see, again, we have these pairs comparing being down in the index versus being up in just individual Fibonacci numbers being multiplied by other Fibonacci numbers. So here I'm going to pause and let you work on this one yourself. Determine which Fibonacci number this is. So the 3 and the 4 are being multiplied down in the index. So 3 times 4 gives us 12, and we already know the 12th Fibonacci number is 144. And here the difference is the multiplication is not down in the index, it's just up with the numbers. So we want the full third Fibonacci number times the full fourth Fibonacci number. So 2 is the third one, 3 is the fourth one. So 2 times 3 gives us 6. And now again, in number 3, right, in the index, right, we're adding 1 plus 2 plus 3. Down in number 4, we're just taking Fibonacci first plus second Fibonacci plus third Fibonacci. So I'll give you a minute to go ahead and try that on your own. Pause the video and see if you can do it. All right, so we go ahead and add all of these up down here first because we have to figure out, well, what Fibonacci number is this telling us to find? And it's the 6th one. So we go down and find 1, 2, 3, 4, 5, 6. It's going to be 8 because 8 shows up 6th in our list. And this one, well, there's no work to do. We already know we want the first one, the second one, and the third one, and we're going to add them together. First, second, and third, well, that's 1, 1, and 2. We add those together and we get 4. All right. The last example of this video, we're going to work with some much larger Fibonacci numbers. So Fibonacci numbers get big really, really quickly, right? 36th one, we know the 12th one in the sequence was 144. The 36th one is 14,930,352. The 37th one is 24,157,817. Those are pretty large. All right, so we want to find two things. We want to find the 38th Fibonacci number and the 35th Fibonacci number. So what we're going to use here is this Fibonacci recursion that says to get 1, you add the 2 previous Fibonacci numbers. All right, so if we want to get the 38th, well, we add the 37th and the 36th, which is exactly what we have in our example. So we're going to add this 14,930,352 to the 24,157,817. And what we get is 39,088,169. All right. So there's that one. Part 2 is slightly trickier. So we want to find F35, and if we do what we did last time, well, the 2 previous are F34 and F33, but we don't have any information about those, so this is not going to work for us. So we sort of have to reverse engineer it. We're going to use the information we have about F36 and F37. And I'll give you a minute, go ahead and pause the video and see if you can figure it out. Well, what we're going to do, right, we want something involving 35, 36, and 37. Well, we could view that as, to get the 37th one, we add F36 and 35. And we know F37 and F36. So what we can do here, F37 minus F36 is going to give us that F35. So instead of adding them like we did in the first one, we take this larger one, the 24 million, etc., and subtract off the 14 million to find the difference. Because whatever that difference is, that's what we added to the 14 million to get that 24 million. And when we go ahead and do this, we end up with F35 is 9,227,465.